In case of fluid also there is pressure. In solid, pressure is normal force acting per unit area. Now we'll check pressure acting in case of fluid. And then at the end, half an hour, I will send you the test paper that you have to solve and send within that stipulated time. Suppose I take fluid in a
Sir, you will be sending it on the group, right?
on the group, I will send yes. If
Sir, so
this
yeah, I'm not being added on the group. So can you send it to my mother and then she'll forward it to me? Is it okay?
whosoever is there, no problem. You can check from there.
Okay, sir. Okay,
See,
sir.
this is suppose container. I fill it with liquid. So is it touching the container from all the sides?
Yes.
Yes, because it is liquid, so it will touch from all the sides.
Yes.
That means it will exert pressure everywhere, na? On the
Hmm.
container at all sides.
Yes.
So fluid contained in the vessel will exert pressure at all the point in upward direction or in downward direction or in all direction.
In all
In all
directions.
directions. Suppose there will be pressure here, pressure here, pressure here. Same way on this side, pressure everywhere. So solid will exert pressure only normally, but liquid will exert pressure everywhere in all direction. Right. Pressure in fluids. A fluid contained in a vessel exerts. Your school has given you prelim timetable.
Sir, we don't have prelims.
Acha, directly you have got final exam.
Sir, it is at 20th January.
20th January for you, Aditya. A fluid contained in vessel.
Yes, sir.
You have got test on when, which day?
9th Jan.
9th January. A fluid contained in
And the
vessel.
marks is 40 and 6 to 10 chapters will come.
I will keep one or two extra like this. A fluid contained in a vessel exert pressure points, at all points and in all directions. This thing will ask mostly in finger blanks. Write this. Pressure and fluid. Fluid contained in a vessel exert pressure at all points and in all directions. Yes, you have completed.
Yes, sir.
So if I consider liquid taken in a container and make two holes. One at height H1, second at height H2 from the surface. At height H1 and height H2 from the free surface of liquid. Height H1 from free surface, height H2 from free surface. It is found that from here the liquid will fall closer as compared to from here. That means who is applying more force? One which is closer or which is away from the free surface? See, again,
Away.
this is container with two openings. One is away, other is close to the free surface. So somebody rightly said the liquid from free surface will fall closer to the free surface, will fall closer, the other will fall at larger distance. To travel large distance, there should be more force. If there is more force acting per unit area, indirectly I can say there is more pressure. So can I say bottom will exert more pressure as compared to one which is close to the top? So by this,
Yes.
we can demonstrate that pressure will increase if the distance or height from the free surface of liquid will increase.
Yes.
Okay. State formula for pressure due to liquid column. The derivation is not there, so I have written state formula for pressure due to liquid column. In shortcut, I am explaining you the formula. If this is container, so this will be the weight of the liquid in the container acting normally, or you can say vertically downward on this base area. Is it true? Is it correct?
Yes.
So
Yes, sir.
this area is suppose A. So I can say pressure is due to weight which is creating force upon area. Weight means
Hmm.
mg or not? Weight is mg of the
Yes.
upon
Yes.
area. What is density formula? Is it mass upon volume?
Yes.
So can I say mass is density into volume
Yes.
into g upon area? What is volume of the liquid here of contained in the container? It is nothing but area of base into height. Volume.
Yes,
Suppose
sir.
so density volume is area into height into this g upon area. A will get cancelled. So can I say pressure due to liquid column is H rho G. Here what is H?
Height.
From where? From the free
Free
surface of,
surface.
that means from top. And what is rho? Density of liquid. And what is G? Acceleration due to gravity. Okay. So if they say state formula for pressure due to height of liquid, you can write like this. Pressure due to liquid is pressure due to liquid is given by P equals to H rho G, where H is depth or height of liquid from free surface. Height of liquid from free surface. Rho is density of liquid. G equals to acceleration due to gravity. Write this formula and meaning of the terms. Once you complete, then please tell me.
Sir, P is क्या density of liquid ना?
Rho equals to density.
हाँ, rho.
This is rho. P means pressure we have written. Pressure due to liquid is given by P. This is rho. If you complete, please tell me.
Sir, done.
Everybody has written full?
Yes, sir.
Okay.
No, sir.
Arre, लिखो.
Sir, in our school, they have completed one chapter of maths. One chapter of maths, mensuration chapter, they have completed in 2 days.
That is very lengthy chapter. How they completed?
That only, sir. You know what she did? She did alternate sums. 3 hours daily.
Yes, you all have completed writing this.
Yes, sir, done.
Okay. Now, suppose this is water surface. Water surface, and then water level is increasing. If somebody is swimming here, what is pressure acting on him? On this person, what will be pressure acting?
Zero.
No, atmospheric pressure. Because above the surface there is atmosphere. So what is pressure acting here? Here in surface, no zero pressure. Don't say zero. What it will be? Atmospheric pressure.
Atmospheric
So
pressure.
when he starts swimming inside, now what is pressure acting? If he is at height h from free surface, atmospheric plus due to height. So it is atmospheric plus h rho g. This is called total pressure acting on the body if it is at depth h from the free surface of liquid. Okay. So if given atmospheric
सर
pressure,
ये लिखना है
हाँ मैं बताता हूँ क्या लिखना है. लेकिन suppose they ask in numerical, they say atmospheric pressure is x, pressure due to height is y. What is total pressure? X plus y. So next line you will write total pressure acting on a body at depth h equals to atmospheric pressure plus pressure due to liquid. Atmospheric pressure plus pressure due to liquid column. Therefore, total pressure Pt equals to atmospheric plus H rho. Right, this much. Written?
Done, sir.
Very important questions. Vectors affecting the pressure at a point with a pressure. Vectors affecting the pressure at a point in the liquid. See, we can see pressure is H rho G. So that means it will depend upon three physical quantities. One is depth, other is density, and third is acceleration due to gravity. The pressure at a point in a liquid depends directly on three factors. What are those three factors? The depth from free surface of liquid denoted by H. Second, the density of liquid denoted by rho. And third, the acceleration due to gravity denoted by G. Guaranteed they will ask you this for 2 marks. What are the factors on which pressure at a point in liquid depends? It depends upon three factors: depth from free surface of liquid H, density of liquid rho, acceleration due to gravity G. Copy this, the three factors.
Done, sir.
Okay. So pressure depends upon these three things: H, rho, G. Next line you will write: it does not depends upon shape, does not depends upon shape and size of vessel, or you can say container. It does not depends upon first shape and size of container. Second, the area of base on which liquid acts. Area of base on which liquid acts. So if they say on which two factor, it does not depends. Shape and size and area of the base on which liquid acts. Final exam for PPS date is declared. Final exam date
Nice assessment.
Yes, sir.
for PPS they have told.
18th of January.
Final exam.
सर वो assessment final नहीं है.
This is to evaluation exam, na?
सर नहीं 18th of January से assessment 3 start होगा.
No. There will be 4
Sir,
assessment.
भी
नहीं
assessment
सर ये
ये 2 हो गया.
MCQ टाइप है.
Acha. So final when they were going to
Yeah.
give?
Final February और
सर
March
अभी
में.
MCQ होएगा फिर सब्जेक्टिव उसके बाद होएगा.
Acha. So at least 1
Final.
month they will give you, na?
हाँ.
Okay, because I have to keep 3 chapters, 4 chapters cut together test. After January we'll start with that test series. Completed? Laws of liquid pressure. Your teacher has completed this chapter?
No sir, just begun.
Just started. Laws of liquid pressure. That's why you don't take tension. Whatever they are going to complete, that only they will ask. Laws of liquid pressure. There are 5 laws of liquid pressure. There are 5 laws of liquid pressure. Just complete so that I can clear this and explain you one by one what are these 5 laws of liquid pressure. Should I clear this now?
Sir.
Okay. There are 5 laws of liquid pressure. First one. First, it is simple. As we go on moving inside, the pressure will go on increasing. So inside the liquid.
सर और अपने कितने चैप्टर्स बाकी है?
एक चैप्टर एक बाकी है ना अपना buoyancy and upthrust.
Okay.
Inside the liquid. Now there is no board exam, na? So no need to worry. If it is board exam, then all
Yes sir.
now it is whatever.
Pre-board is cancelled.
So whatever teacher will complete, that will come in the exam. Inside the liquid, whatever you are doing, do that perfectly. Because in 10th, they may not delete in the coming year. Everything will be there. So if some concept of 9th is there, you have to understand in 10th. Inside the liquid, pressure increases with the increase in depth from the free surface. That's why we have base of dam broader so that pressure can be withstood by broader surface area. So inside liquid, pressure increases with increase in depth from free surface. Write down first point properly. Completed?
Done, sir.
This is free surface of liquid. I'm considering one layer of liquid. In this layer, one horizontal plane. If P, the height is 10 centimeter, what will be height of Q? What will be height of Q in same layer? Will it be same or different? Hello? Hello?
Yes, sir.
All the liquid particle in same horizontal plane, they will be at same height from free surface or different heights?
Same height.
If same height means what will be the pressure on all the liquid molecule?
Same pressure.
Same pressure, because height is same, density is same, G is same. So can I say in stationary liquid, pressure is same at all points in the horizontal plane. So right, second point, in a stationary liquid. When you take liquid in container, it is stationary. Sea water is not stationary. So in a stationary liquid, pressure is same at all points in all points on a horizontal plane. Second topic. In fact, it is based on height only. In a stationary liquid, pressure is same at all the points on same horizontal plane. Completed 2 points. Can I clear it off? Yes, can I clear?
Yes, sir.
Now imagine this is one container containing liquid. Containing liquid. Somebody is standing here, floating here in this direction. Other person is floating in this direction. Third person is in this direction. Who will experience more pressure? One who is facing right or left or facing inclined. Who will experience more pressure?
Inclined.
Pressure inclined.
Inclined.
नहीं, सबको सेम मिलेगा. एक ही प्लेन में ना वो लोग. ऐसा 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 हाइट चेंज हुआ क्या from the surface? This height, is it changing the height? No, no. Suppose this is water surface at some height.
नहीं बट सर फिर भी जो
I am
inclined
floating.
उसको
नहीं, inclined मतलब पैर वाकड़ा नहीं किया है
मुंह
वो.
पे ज्यादा प्रेशर आएगा ना.
नहीं बेटा देखो, inclined मतलब ऐसा है ना, यही surface पे. तो उसके ऊपर तो ऊपर सेम एक्ट होएगा ना. Inclined से कोई
But
थ्री
sir-
डायमेंशनल है. Imagine पूरा पानी का सरफेस है, कोई हॉरिजॉन्टल है राइट में, कोई हॉरिजॉन्टल लेफ्ट में, कोई थोड़ा इंक्लाइन, तो सब तो वही सरफेस पे ना. तो सबके लिए ऊपर से हाइट सेम है क्या अलग अलग है?
सेम है.
सेम है. हाइट सेम तो एच रो जी क्या होएगा? सेम हो गया ना.
सेम होगा.
हाँ, इसलिए प्रेशर विल रिमेन सेम. अब इमेजिन करो, इफ आई कीप द बोल ओपन दिस वे और दिस वे और दिस वे.
बट अगर सर वो अगर स्लाइटली इंक्लाइन के जगह पर पूरा परपेंडिकुलर होता तो फिर
परपेंडिकुलर होएगा तो वो ऐसा वर्टिकल हो गया ना, तो उसका बॉडी एयर में
हाँ,
तरफ.
हाँ.
तो ये केस नहीं कर रहे हम. कौन सा केस सोच रहे हैं? एक ही जगह पे अलग अलग डायरेक्शन में ऐसे ऐसे
ओके.
ऐसे. इमेजिन करो ना, एक बुक ले लो. बुक अपना फ्लैट सरफेस है, उधर पेन रखो,
हम्म
राइट में, लेफ्ट में, इंक्लाइंड, तो सब एक ही जगह पे आ गया, एक ही पॉइंट पे। तो अभी ऊपर रखेंगे तो अलग हो जाएगा ना।
हाँ
So pressure is same in all direction at same point in the liquid. That means if this is the point in the liquid, so pressure इधर साइड से, pressure इधर का साइड से, इधर के साइड से, सब साइड से सेम, ये मीनिंग है, क्योंकि हाइट सेम है ना ये प्लेन में इसकी। Everybody has understood concept?
yes sir, got it.
Okay, third point, write down.
Repeat करोगे?
See, suppose this is horizontal plane, okay? Somebody is floating like this, somebody is floating like this, somebody is floating like this. So all are in the same plane. Therefore, the pressure is same on all. Hello? You have to imagine this is, suppose there is water surface. Same height पे दो जन आमने सामने ऐसा एक दूसरे पे, तो दोनों पे प्रेशर सेम होएगा ना। We are talking about stationary. अगर फ्लोटिंग रिवर रहेगा तो जो रिवर की डायरेक्शन में उसको पढ़े नहीं समझा?
समझा।
तो third point, write down. Pressure is same in all direction. The pressure is same in all direction. Pressure is same in all direction about a point in about one point, pressure remains same. From whichever side you apply the pressure, it will remain same. Actually, सब height related ही है। ये point को इधर से measure करूँ height, या ये point को इधर रखा, ये plane पे height तो same ही रहने वाला है हर जगह पे। Fourth point, pressure at same depth, that means same height. Pressure at same depth is different for different liquid. Can you tell why? Can you tell why pressure at same height is different in different liquid? Can anybody explain me why?
Sir,
Yes.
because different liquid have different density, so
Correct.
there would be more dense
Pressure at
pressure.
same depth is different in different liquid, because if density
Yes, sir.
increases, then pressure will increase. Right, fourth point. Pressure at same depth is different in different liquid, as different liquid has different density. Different liquid has different densities. Fifth point is most important. First write down, then I'm explaining the meaning. A liquid seeks its own level. Liquid seeks its own level.
Sir, at what time you will send the test paper?
What time you are comfortable so that you can start with good mood?
I don't know. I was asking you at what time you will send.
I think I should send at 7:45 so that in half an hour you can complete it. And our portion is also going ahead.
Sir, then at 7:45 can we log out?
7:45, 8:15 you have to submit.
No, at
Sir, I
8.
didn't get it.
Pardon, what you're saying?
I didn't get the procedure.
At 7:45, can we leave the meeting then?
No. You have to be connected.
Okay.
Uh,
Okay.
you have to be connected. Keep your video on. Write the test. I will be observing, and at 8:50 you will post it. How
At
is 15, 1 5?
8:15.
How is the idea?
Okay.
Must idea.
Half an hour.
Half an hour test. A
Yes.
liquid 6 its own level. Completed. I'm explaining what is meaning of liquid 6 its own level. Everybody has done all the 5 points.
Yes.
Okay, I'm clearing this to explain you the meaning of liquid seeks its own level. Suppose pressure, I'm just giving example, is 100 Newton per meter square. If I take liquid of density 1, G is 10. So what should be the height of that container to get answer 100? Pressure means H rho G. This is 100. Height I want. This is 1. This is 10. 0 cancel. What will be height? Hello Ryansh, what will be the height? Yes, Aksham, what is height?
So 10.
Yeah, it's clear cut 10 by cancelling this 10. So if I take container of this shape, then it will be 10. Or if I take container of this shape, then it will be 10. Or if I take container of this shape, where it will be 10. If I want pressure 100. हर एक में 10 ही आएगा ना 10 10 irrespective of the shape. So that's why it is given. It will seek its own level. So it will seek level of 10 irrespective of the shape of container. Got it? Meaning? Hello? Hello? Hello?
Yes, sir.
Yes, sir.
Okay. Now few consequence of liquid pressure. I'm explaining.
Sir, Lakshmi is traveling, so she won't be attending the meeting and not even the test. So she was asking if she can write the test later and send you.
अरे ना इंसाफी ना उन्नति.
So she is traveling.
अरे आप लोग बेचारे इतना टेस्ट लिखोगे वो बाद में लिखेगी. क्या बोलते हैं आप? दे दो उसको. अलाउ कर दो.
सर दे दो.
अच्छा ठीक है चलो दे दिया अलाउ कर दिया. And this lecture also I'm recording so you can listen later. Some consequence of liquid pressure which depends upon H fluid. Mostly give reasons they will ask. At same height हाँ जरा ध्यान से देखना same height means same depth. Pressure in sea water is greater than in river water. Why? Pressure in sea is greater than pressure in river at same height.
Because of the salt concentration.
Because density of sea water
It has
is
added
greater
salt
than
in it.
so density of iodine salt it has.
No, sir.
Added salt. अच्छा added salt.
Added salt.
I thought वो टाटा का नमक खाता है देश का नमक. So density of sea water is greater than density of river water. Therefore, pressure of sea water is greater than pressure of river. Clear?
Yes, sir.
Second consequence. Why the base of dam is made broader? Dam.
To withstand the pressure of the water.
Because as you move downward, height increases, pressure will increase. तो ये लैंड में पानी रखा है. Height increases, pressure नीचे ज्यादा होएगा. इसमें slanting pressure area बढ़ाते जाता है. The base of dam is made broader to withstand high pressure due to depth. Clear this also? Is it clear with you all? This also?
Yes, sir.
Third one. Water supply tank is placed at height. If I take water at high level, that means height has increased na, from the surface. If greater the height, then pressure will be more or less of liquid column.
Less.
More.
More, na height ज़्यादा है ना from the see.
Sir,
Yeah.
if you're talking about the lower level or high level?
No, we are
Lower
talking
point or
about
high
in
point?
general. See, ऐसा ये water tank. Tank height is negligible as compared to the height of the tower on which it is placed. Suppose this is one tower of 100-meter height, and here there is a tank of just 2 meter. So ये 2 meter is negligible. ये height. So from the bottom ये height ज़्यादा हो गया.
Yes, sir.
तो इसका ऊपर pressure ज़्यादा होएगा ना, because H is more. Hello.
Yes, sir.
So if I open the tap here, it will move with faster speed because height is greater. So pressure of water in the tap will become more because it is falling from greater height. So whenever you have to supply water, the tank to store water is made at sufficient height. In our building, first what BMC water comes, we store on the ground. Then by water pump, we take at the height. So actually we are increasing potential energy. Energy is nothing but capacity to work. Work is nothing but force. Force is nothing but pressure. So all are connected. So when the tank is at higher height, then the pressure of water in the tap of a house will increase. Thus the supply can be maintained easily. That is one of the advantage of placing the tank at higher level as compared to the tap. How many of you have done scuba diving?
I have.
You have done? Where you have done?
Goa.
Wow. Uh, before we do scuba diving, they train. No, they train us. This will be the signal. Comfortable है तो ऐसा finger गोल करके बताओ. कुछ तकलीफ हो रहा है तो show your fingers upward so that you can move up. This all training they do, correct?
Yes, sir.
Some special dress also we have to wear. Some special suit. तो ये special suit क्या disco suit रहता है?
To protect us from the pressure of water.
So it is made up of reinforced glass plus rubber का mixture होता है. So that suit will
So
withstand
how
the
can we
pressure.
mix glass and rubber?
Glass can be done in molten form by heating. Silicate is
But
called
rubber will melt now in glass.
reinforced
because
rubber
of
means
high.
it is mixed with cotton. When it solidifies, we have to melt only. When it solidifies, it will behave like a glass rubber reinforced rubber. तो दोनों को गर्म करके मेल्ट कर देते साथ में. एलॉय कैसे बनाते हैं?
Yes, sir.
तो इसका भी मेथड वही है. दोनों को मेल्ट कर देते हैं, मिक्सचर बना देते हैं, सॉलिडिफाई करके इसका डक्टिलिटी ज्यादा रहता है, ऐसा रहता है डक्टाइल, so it can be drawn into thin sheet. So this we have to wear special protective suit to withstand the high pressure due to liquid column. That's why the divers wear this suit. If this is water, here there is one bubble. It comes here. What will happen to the bubble?
It will blast.
Just before it is blasting, what will happen? Will the size remain same or it will change?
Sir, it will increase.
Why it will increase?
Sir, because of the pressure.
Have you heard about Boyle's law in chemistry anytime?
Yes, sir, I have heard.
You have heard?
Boyle's law and Charles' law.
Boyle's law is what? At constant temperature, pressure and volume are inversely proportional.
The pressure, the volume of a given dry gas, like that.
The pressure on given mass of gas at constant temperature is inversely proportional to volume. Inverse मतलब उल्टा. So pressure here is atmosphere. Pressure at bottom is atmosphere plus liquid का height. So here pressure is more, so volume will be less. ऊपर है तो volume ज़्यादा हो जाता है ना. Hello. Hello.
Yeah.
Sir.
So can
Yes,
we
sir.
say when the air bubble rises on the surface, its volume increases or size increases due to pressure decrease. This is one of the consequence. This is how they can ask you. All this consequence ka give reason I will send you printed form, written form. Now we are doing last part of the chapter which is there in the syllabus. Pascal's law and one application. Have you heard about Pascal's law? State Pascal's law is again guaranteed question to be asked in your school PPS. State Pascal's law. Suppose this is liquid, enclosed liquid. Spherical बताया था. इधर से एक होल किया तो liquid will come out. Correct है?
Yes, sir.
इधर होल किया तो भी liquid बाहर आएगा ऐसे. ऐसा नहीं आ रहा. If I take a
Sir,
spherical
can I
body.
join through another device?
Okay, join fast.
Sir, admit करना.
This is one spherical balloon fitted with piston. Here I've got all small pistons. Small pistons. Small pistons. तो इधर से अगर प्रेशर दूंगा ना, अगर ये 2 सेंटीमीटर कम होएगा तो ये सब में 2 सेंटीमीटर ऊपर आ जाएगा ना, अगर सबका एरिया सेम है तो, है ना? Hello.
Yes, sir.
Yes, sir.
So Pascal suggested that if liquid is taken in a closed container, then if pressure is applied at one point, it will be transmitted at every point of the liquid. Undiminished. What is meaning of undiminished? कम हो जाएगा क्या ज्यादा होएगा or it will remain same? Pressure will remain same or it will increase or it will decrease? Hello?
So repeat करोगे?
Yes, I said according to Pascal, if liquid is taken in a closed container, if pressure is applied at one
Increase.
point, then it will be transmitted at all other points undiminished.
Yes, sir.
Undiminished means no change. No change in the pressure.
No. There will be change, no? If we'll apply pressure, then
That
the
is
pressure.
Pascal's law is saying there will be no change. If it is closed liquid, like suppose this is one cylinder, I connect it to another cylinder of different area. So here if you apply pressure of 100, this pressure will go here and also will remain 10. Force will change because of area. Pressure is not changing. Pressure applied at one point is transmitted undiminished on any other point of the same liquid. That law is called Pascal's law. Based on this, we have to study hydraulic machine, principle of hydraulic machine. So just to write Pascal's law because time is less for your test to be started. Right, Pascal's law. It states that, very important, guaranteed question to be asked in the exam. It states that the pressure exerted anywhere, it states that the pressure exerted anywhere in a confined liquid, pressure exerted anywhere in a confined liquid is transmitted. Pressure exerted anywhere in a confined liquid is transmitted equally and undiminished in all directions. Is transmitted equally and undiminished in all directions throughout the liquid. It states that pressure exerted anywhere in confined liquid, confined matlab closed liquid, is transmitted equally and undiminished in all directions throughout the liquid. The pressure exerted anywhere in a liquid, confined word if you don't write, teacher will cancel 1 mark out of 2. In a confined liquid is transmitted equally and undiminished in all direction throughout the liquid. In all direction throughout the liquid. Pressure exerted anywhere in a confined liquid is transmitted equally and undiminished in all directions throughout the liquid. Yes, you all have written this much? Everybody has written till this?
Done, sir.
Now you can see the question
Yes, sir.
given. Can you see I have sent one question?
So I am not having my phone right now.
What you are not having?
Sir, I am telling that I don't have my device right now. Like another device. Sir,
Collect the
can you share
device.
the screen?
Sir, yeah, sir. Can you share the screen?
No, it is not on the screen. It is in the mobile which I have sent you. Only the
Yeah, so you have sent it in the group, no?
in the common group. Only question 7th, you don't have to do that question. I'm giving the other one. Draw ray diagram for image of an object due to convex mirror. Rest all you have to do 7th in place of that question. You have to attempt this. Have you written the question? Draw ray diagram for image of object due to concave mirror.
Sir, this is the question for
Yes,
writing.
for last 7th one. No need to write, it is easy to remember. Ray diagram for convex mirror.
Sir, you can share the screen, please.
I can't share because I have sent you on the Mobile. So much I am telling, then also you are not understanding.